Hey, this is Presh Talwalkar. A square pyramid has base PQRS and vertex O. Each edge has length equal to 20. Calculate the shortest distance along the outer surface of the pyramid from P to T, where point T is the midpoint of OR. Pause the video if you'd like to give this problem a try, and when you're ready, keep watching to learn how to solve this problem. Let's focus on the pyramid. There are essentially two paths we can take from point P to point T. One path will go along the square base and then a triangular face. The other path will go along two of the triangular faces. To calculate the length of each of these paths, we will unfold the pyramid onto a flat surface. There are two cases to consider. In one case, each of the triangular faces unfolds to a different side of the square base, like the petals of a flower. In the other case, two of the triangular faces are attached to each other on the same side of the square base. Let's calculate the length of the path PT in each of these cases. In the first case, we want to calculate the following length, which goes from P to T. Notice P and T are points in the plane, so this straight line segment will be the shortest distance between P and T. This is the point R for reference. To calculate the length of PT, we will construct the following right triangle. Since each edge length is equal to 20, and T is the midpoint of OR, RT will be equal to 10. Next, each triangular face is an equilateral triangle because all three sides have the same length. So each of these angles is equal to 60 degrees. We thus have a 30, 60, 90 right triangle with a hypotenuse RT equal to 10. So the shorter leg will be equal to 5, and the longer leg will be equal to 5 times the square root of 3. To calculate the remaining distance along this side of the triangle, notice its length is exactly equal to the side length of the square, so it's equal to 20. To calculate the remaining distance, we take 20 minus 5, which is equal to 15. We can thus calculate that PT is equal to the square root of the sum of the squares of 15 and the quantity 20 plus 5 times the square root of 3. So in this case, PT has a length equal to the square root of 225 plus 400 plus 200 times the square root of 3 plus 75. We simplify this to get PT is equal to 10 times the square root of the quantity 7 plus 2 times the square root of 3, and this is approximately equal to 32.348. We'll keep this value in mind, and now let's calculate the length of PT in the other case. We want to calculate the following length of PT. This is the vertex O. Each edge in this pyramid has a length equal to 20. And then T is along the midpoint, so we know that this length is equal to 10. Each of the triangular faces is an equilateral triangle, so each of the angles is equal to 60 degrees. We can now calculate the length of PT using Al-Kashi's law of cosines. The length of PT will be equal to the square root of 20 squared plus 10 squared minus 2 times 20 times 10 times the cosine of 120 degrees. We simplify this and we get that PT has a length equal to 10 times the square root of 7, which is approximately equal to 26.458. And this is shorter than the length of PT in the other case. Therefore, the shortest length from P to T is equal to 10 times the square root of 7, and that's the answer. Thanks for making us one of the best communities on YouTube. See you next episode of Mind Your Decisions, where we solve the world's problems one video at a time.